listen to the recording, but we're going to go through all the different ways you could use distributive property and what that means, besides just the rectangle area, what we did yesterday. So I want you just to take a look at the method on number 7, for example, on the left here, okay? And I just want a show of hands. How many people actually had 2 methods? Cody, get your paper out. Okay, stop dancing. Color correct. Okay, you had 2 methods? Did everybody? Everybody had 2 methods. Raise your hand if you had exactly these 2 things on your paper. Nobody had exactly those 2 things on their paper because no hands are up? One person?
Well, I had it too.
Okay, so this is what they said on the homework.
Yeah, but I didn't.
Okay, so the whole.
Yeah, but it's just in a straight line.
Right, so that's my point. That's what I want you to do when you take out your color correcting pen, is I want your homework to have these 2 methods on there. If you only have one, add the other. If you don't have either, add both. Because you're going to get more practice and then you're going to have something to look at. Raise your hand if you don't really understand what I did. Only one person? Okay, a few, right? So if I took you back to the beginning of the problem, that would probably be more helpful, right? Okay, so let's do that. Let's get rid of everything but what you saw in the homework. This wasn't there yet, right? And this wasn't there yet. Okay, so in the homework it said, find the area of the big rectangle 2 different ways. True? Okay, so what I did in the board yesterday was, using that area model, I said, what's 3 times 4? And we would put the answer to that in this part of the box, because I'm multiplying these 2 numbers. Do you remember that? Okay. Everybody? All right. And then in the other box, I asked what 4 times what? What would go here? Zoe? Yeah, because it's 4 times 6, right? So it would be 24. Raise your hand if you remember doing that yesterday. Okay, so one of the methods is, and you should be able to write the steps out, that's what I want to make sure you have, is that you did first 3 times 4, and then you added that, because you end up adding the 2 areas together. You added that to 4 times 6. And then 3 times 4 was 12, and 4 times 6 was 24. So when we add them together, we get 36. That's one method. Raise your hand if that makes sense. Okay, I see about a third of the hands. Don't raise your hand if you don't have to be polite. If it doesn't make sense, you don't have to raise your hand. Okay, so let's try a second method. We'll try a second problem, okay? So the other method would be to think of this rectangle as one big rectangle, which we also talked about, but we didn't focus on it. So one big rectangle would just be thinking of this whole length as, the width is 4 times the whole length, which is 3 plus 6, because if this is 3 and this is 6, how long is the whole thing? Yeah, Jason, 9, right? So our method is to do 4 times 3 plus 6 and do the 3 plus 6 first, so we put parentheses. And 4 times 9 is 36, so we get the same answer in a different way. So Neve, you're one of the kids that asked, but you're a little caught up in your snack there. You can't even see, right? I want to make sure that you're paying attention when you ask. Okay, does that help at all? So if I went to the next problem, number 9, the two methods come from doing 3 small rectangles, where this is 5 times 3, and then I would add it to 5 times 6, and then I would add it to 5 times 2, and that's what I have here. Do you see that? That's what method 1 is. But I'm actually writing out the steps, because the author asked you to write your steps out. So if you don't have your steps out, you should have your homework out. You should write them in. Keely, where's your work? Okay, so you should bring it in Monday morning and check your work.
Same with you, Rosa.
Okay. Ava, you got it? That makes sense? So one method is just method 1, where you do the parts of the rectangle. Method 2 is looking at the whole rectangle, which means we're going to do 5 times 3 plus 6 plus 2 right here, under method 2. So, all right, so flip your homework over. Try a practice problem. Try this problem for me. Do 2 methods. Add it to the back of your homework. Cody, give me one of your methods.
Well, my first method
Nice and loud so everybody can hear.
5 plus 3 times 6.
So he used like the parentheses. So 5 plus 3 times 6. Usually, Cody, you'll see the 6 in front. But it's not wrong to write it this way. It's less common. That's all. Okay, so is that what you meant? Okay, so then your next step would be parentheses. Do you remember that from elementary school? You always work in parentheses? So you'd have 6 times what, Cody?
6 times 8.
Good. And so 6 times 8 is? So the area of that big rectangle. So he basically did the yellow the whole big rectangle instead of the parts. Okay, so method 2, Ian.
So I had 6 times 5.
6 times 5,
Then 6 times 3.
then 6 times 3. Perfect.
But I had 6 times 5 on top of 6 times 3, and I had an equal sign showing what they were. Then I had 13 plus 18 equals 48.
And that's okay, Ian. What I would say is, in a problem like when the problems get bigger, you don't see, you wouldn't see it stacked, I guess is what I'm saying. Like this is what you're saying? You kind of went like this? You won't see that much, because what happens is the problems get really long and the stacking gets confusing. So, that being said, your method is correct. Those are the 2 methods.
Well, I have different kind of method.
Tell me what you did.
So what I did was I did 6 times 5 plus 6 times 3, then I put an equal sign, and I did 30 plus 18.
So again, you went sideways.
Yeah.
Okay. I'm really glad you guys brought that up. So Miss Haley, I'm pretty sure you do this all the time anyway, but just in case, I know Miss Stoneman does. Miss Stoneman's one of the other teachers in the building, and she was really good about teaching kids to think of everything as a funnel. Like your answer comes out of the bottom of the funnel. And she's really like particular about that. And when you work and put equals to the right, it gets really confusing because there's going to be so many steps, Landon, that you want to learn to work below your problem and to the right instead of to the right of it. And today I'm going to show you bigger problems where you're going to see why that's true. Okay? Need.
What if I did my method 1 in the box?
If you did your method 1 in the box, I do it all the time. I mean, I do this all the time.
No, I mean, like, what if I put like 30 and 18 and then...
Yeah, you can work in the box, but you should still be able to show this step if you needed to. Because we're going to learn something today with order of operations. And last night's homework was sort of trying to train you to read problems like this. So that's why they wanted you to write the steps out. So if you put your method in the box, I would just write it out below. Sounds like you did it right. Okay.
Melissa did her homework. Pretty much did it right.
Yeah. Great. So problem 11. Who has an answer for problem 11? Do you, Courtney? Yes or no?
No.
Okay, Nathan, what do you have?
I have, so, it already, like, so you have 7 times 3.
Oh yeah, I kind of have a little bit down there, huh? So what goes in these missing spots?
7 times 3.
Like what number up here?
7 times
Okay, so let's write out what you're saying. 7 times 3. What else?
4 times 7.
And I'm going to say in 7 times 4. Okay? He's right. If I were going to put numbers in the boxes, does anybody know what number would go there? Yeah, Zoe? The 7. So, because when you look at, so good job, both of you. When you look at 21, the factors of 21 are 1 and 21 and 3 and 7. And you're trying to look at the factors of 28, 1 and 28, 2 and 14, and 4 and 7. So you know how we work so hard on factor pairs? This factor is common to both, right?
Yep.
We were looking for one number that we would put here that could help me get area for both of these numbers. So 7 times 3 gives me the 21, like Nathan said, and 7 times 4 gives me the 28. Do you see how they also, so I guess what I'm saying is if you have a picture like this with boxes where you're supposed to fill in the missing values, you also want to be able to put the values in the yellow boxes, for example. Does that make sense? Got it. Got it. Landon?
I put 8 on accident.
But it's similar, right?
It's kind of like 709.
Yeah. That's okay. It's good practice. Okay. Now I bet 17 was exactly like the video, so people probably thought that one was easy, right? Easier?
Sure.
So did you get 306 in the end?
How many of you guys watched the video?
Well, or in class, we did the exact same problem, same type of problem in class.
306.
Any questions on that?
306.
Grace, how are you doing? Better? Were you the ones that asked a little bit different than the home notes? Does that help? Okay. Last problem. 19 is really different, so we're going to just do 19 from the beginning. So as soon as everybody's ready to do some listening and participating, I'll start. Okay, I'm going to start off 19. It asks for different ways to get 60 with addition. So like I could do 30 plus 30. How about you, Rosa? What's another way? Another way to get 60? By adding 2 numbers. Keep working on it. I'll come back to you, Leah. Come up with one, Rosa, in a minute. 20 plus 40. Did you get one, Rosa? Nice. Okay. There's so many possible answers on part A, but that was the idea. Okay, so you can look at your paper and see if you have two numbers that add to 60. But in part B, Zoe, it said come up with two numbers that multiply to give 60. So give me some examples. 30 times 2, right? What's it one? Hannah. 20 times 3. Grace. Courtney, I mean. Sorry.
I got 6 times 10.
Okay, 6 times 10. Okay. So, Pam, what's another one?
4 times 15.
4 times 15. Landon?
5 times 12.
5 times 12. Cody? 1 times 60. Right. So, part A and part B were pretty easy. Part C was weirder. So, let me give you an example of C. What they were saying is, find a way to get 60 with multiplying one factor of 60 by the sum of another, by another factor written as a sum. So for example, you could write 30 as 10 plus 20 and then multiply it by 2. Because if you have parentheses, you would get 30, right? And 2 times 30 makes 60. You see that? Can you make one for me? Make one. So do something where you have a multiply one number times the sum to get 60. Who can do one? Then share with the class a different one. Courtney.
You can do 6.
6 times.
5 plus 5.
Okay, 6 times 5 plus 5. Nice job, because 6 times 5 plus 5 is the same as 6 times 10, which is 60. There's a reason they did this in the homework. They're trying to get you to read order of operations. Ian, give me one.
15 times 3 plus 15.
15 times 3 plus 1, because, oh, he said 15 times 3 plus 15, like that, right? Is that what you meant? That's right, but it's not what they're asking. But it's the right idea. It's still order of operations, so they're trying to get you to use parentheses ones. So 15 times 3 plus 1 would be the same as 15 times 4, which is also 60. So the actual answers they were looking for were things that look like this. Let's just hear a few more, and then we're going to move on.
15. Who came up with that?
Well, it was a cooperative solution, right? Ian, you want to try a different one, Ian? I'll come back to you after you think about it. So, Gavin, Friday.
3 times 3 times 10 plus 10.
Right, Zoe.
4 times 10 plus 5.
Right. Ian, did you get one?
I was thinking of that one.
Okay.
Do somewhere to 4 times 10.
But that's the right idea, Nee. 5 times 10 plus 2. Okay, raise your hand if you understand now. Did you make some corrections to your homework? Okay, so let's put that away. I'm going to just post this as 4.2 homework problems.